Now let's see this question. In a simplified computer, the instructions are given like this: op ri rj ri. It performs rj operation ri. So it means that in our this particular representation op rj ri, this instruction corresponds to, we are applying this operation between rj and ri and stores the result in ri. So I'll explain you what it means later. And next one is op m comma ri performs value op ri and stores the result in ri. Value denotes the contents of the memory location m. So which means whatever is present in this memory location m, that is being denoted by val here. And the next one is move m comma ri moves the content of the memory location m to the register ri. So it means that here if you see the memory location m, so whatever contents are present there, it is going to move it into the register ri. And the next one is move ri comma m. It moves the contents of the register ri to the memory location m. So they are explaining what each operation is actually doing there. The computer has only two registers and op is either add or subtract, add or sub. Consider the following basic block, and this code is given. So before looking at the code, I'll tell you what these operations are doing exactly. Now if you're going to write add, in place of op you can either have add or subtract. Okay, now if you write add r1 comma r2, now the meaning of this one is you will compute r1 plus r2, which means this operation is applied between these two and the result is stored in the second operand, which means the result is stored into r2. That is the meaning of it. And now both of them can either be registers or one of them can be memory location, right? So if you are going to have one operand already on a register, then the other operand can be provided from the memory. That is the meaning of it. Okay, and now they are saying that assume that all the operands are initially in the memory. So assume that all the operands, so what are all the operands for this code? They are given this code, and now they are saying that all the operands are initially in the memory, nothing is there in the registers. The final value of the computation should be in the memory. So after computing the answer, even that also should be in the memory. Then what is the minimum number of move instructions in the code generated for this basic block? So if you are going to write the code for this basic block, then what is the minimum number of move instructions? That is what they are asking. And options are given as 2, 3, 5, 6. Now you are supposed to use minimum number of move operations, which means these. Now when I write move m comma ri, it is going to load the value of this memory location into the register ri. If I write move ri comma m, it is going to store the value present in ri into memory location m. So load and store. For loading and storing, we are going to use move operation, and for the other operations we have to use the appropriate operations, right? So now if you observe it, we are supposed to use as less number of move operations as possible, or as less number of move instructions as possible. Now if you see this, t1 equal to a plus b. Now we have a and b here. T1 is given as a plus b. Definitely in order to load these two, we are supposed to write move, but then luckily what we have is, once you load one of them into, let's say, a register, the other one can be fetched by the operation itself, which means if you see this, there is op mi comma ri. So if you are going to use this operation, which is nothing but add here, this operation itself is going to load this value from the memory. Therefore load one of them into memory, or load one of them into register from the memory using move, and in order to get the other one, you can directly use the instruction add. Got it? Similarly for the second instruction also, you can load one of them into the register using move, and in order to get the other one, you can use add. Got it? So like that, you can move one of them using move, and the other one you can use the operand itself, right? So this operator can be used in order to move them. And finally, whatever is the result, you will have to store it back. So definitely for storing the result back, you have to use one move, and let's try to minimize the other moves as much as possible. Okay, now let's try to execute this instruction first. So for this one, we are trying to move A into R1, which means this particular A is first moved into R1. Now instead of getting B into R1, or instead of moving B into some register, what I'll try to do is I'll use the operator add. So whenever if I use the operator add, it has the facility that it can directly move an operand from the memory into the register, right? Therefore B is going to be fetched from the memory, and it is going to be added to whatever is already present in A, R1. So what is already present in R1? A. Therefore R1 is going to be equal to A plus B. So finally R1 is going to contain T1. Now for this entire instruction, I have used up only one move operation. Got it? And now for the second instruction also I can do the same. I can move C into R2. C is moved into R2, and instead of moving D explicitly from the memory into the register, we can use the operator add that is going to do the purpose for us. Now what is it going to do? It is directly going to load D into R2, and whatever is already present in R2, it is going to add it up with that, right? So since R2 is already containing C, it is going to add D to C. Therefore R2 is going to finally contain C plus D. R2 is going to contain C plus D, which is already T2. Got it? So T2 is now going to be C plus D. So R1 is going to be, after this one, R1 is going to contain T1, and R2 is going to contain T2, right? Now don't unnecessarily move them out of the registers, just let them be there so that whenever we need them, we can use them without using the move, right? Now next thing is T3 equal to E minus T2. Now again we need the operand E. Now this operand E is in the memory. We have to load into the we have to load into the register. So therefore we should definitely use directly if we are going to load, we are definitely going to use move. But then since T2 is already present there, which is in R2, and there is an operation here which is minus, I can use subtract. Subtract E comma R2 means E minus T2 is being done, and the result is stored in T2 only. Therefore now R2 is going to contain T3. Now again if you see this, for loading E I am not using move, I am just using subtraction. Okay, and now what does this R2 contain? R2 is finally containing T3, and R1 is containing T1, right? Now if you observe it, T3 minus T1 is what is required. Therefore I can directly write subtract R1 R2. So R1 is nothing but T1 and R2 is nothing but T3. So if I write subtract R1 comma R2, then T4 is computed, and T4 is stored in this one R2. Finally the result has to be moved into the memory, that is why we are writing this. Got it? So R2 is finally moved into the memory. Now if you observe it, we tried to minimize the number of moves required, right? So only when it is absolutely required we have used the moves. So if you see the number of moves that we have used, it is 3. Definitely 2 moves are not sufficient. See, the option is 2 is also there. Maybe if you try with 2 moves, see, 1 move is definitely required here, so definitely it is required, and the other move, only with 1 move you will not be able to do all this. Why? In order to perform this operation, one of them can be moved using move, and the other one can be moved using operation. For the second one, definitely one of them has to be moved using move. So at least you need 3 move instructions there, right? The number of move instructions is 3. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.